All right, so in this lesson we will simplify expressions. Simplify expressions that involve fractions with exponents. Fractions with exponents. So, example number 1 reads 2 times 3 over 3. Well, we know if I have 2, I'm just going to show you like this. Actually, let me change the color. If I have 2 and I multiply by 3, I get 6. And then if I divide by 3, I'm back to 2. So if you look at this, I just end up with this 2, right? So why did I multiply by 3? Like, if I was just going to divide by 3. So what you do is, you see this 3? You can do this 3 divided by 3. And you get 1. And 2 times 1 is just 2. That's it. Let's look at this one. If I do 2 times 3, I get 6 times 4. I get 24. And I'm going to divide by 2 times 3, which is, I'm just going to put 6 here. I get 4. So the question is, can I get there faster than this? Well, remember, you can write this in any order. So I could do 4 times 3 times 2 divided by 2 divided by 3. So 2 divided by 2 would just give me 1. 3 divided by 3 would give me 1. So I have 4 times 1 times 1, which is 4. Okay, so now let's try something, like, a little different. I'm going to write this out the long way, actually. This is really 3 times 4 times 5 times 5 times 5 times 5 times 5 over divided by 3 times 4 times 5 times 5. So if I do 3 or something times 3 and then I divide by 3, it just ends up times 1, like the same thing, right? Nothing changes. If I do this 4, like, nothing changes because I divide by it later. If I have a times 5, but then later I divide by 5, it's gone. And then it's gone. So I end up with 5 to the 3rd power. Now there has to be a faster way of doing this, right? So 3 divided by 3 is 1, so times 1, right? We just end up with this times 1, same thing. 4 divided by 4, right? So now we end up with this 5 to the 5th power over 5 to the 2nd power. So in reality, I have 5 times 5 times, well, 5 times, like there's 5 of these, right? 5 of these 5s. There's 2 of these 5s. So how many are on top? There's 5. How many are on bottom? There's 2. How many are left over? There are 3, and they're on top. A shortcut would be you just subtract, right? But it's just easier to think of, like, I have excess 5s on top. I have 3 excess 5s on top. Let's try the next one, see if we can do this. So really we have A times B times B times B times B times C times C times C. We divide all that by A times B times B times B times B times B times B times C, right? So if I multiply all this by A and then I divide by A, it just becomes, it doesn't make a difference. A divided by A is 1. B divided by B 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 is 1. I have no more B's, right? No more pairs of B's. But I have a C and I divide by C. So I end up with C to the 2nd power over B to the 2nd power. Let's see if we can do this a little bit easier, right? So A divided by A is 1. Okay, so now I end up with this craziness, right? B to the 4th, C to the 3rd, over B to the 6th, C. Maybe I should make that 6 a little better. So I have 4 b's on top, 6 b's on bottom. How many are left over? 2. And are they on the top or the bottom? They're on the bottom. So I have 4 b's on top, 6 b's on bottom. There's 2 left over on the bottom. Well, I'm actually going to write like this. Okay. And how many c's do I have on top? 3. How many c's do I have on bottom? 1. How many are left over? 2. Oops, that looks a little weird. That's it. So instead of showing all this, I'm just going to jump to the answer, right? Let's do green. So 10, okay, now this is weird, right? I have like 10 and 2. 10 and 2. Like, I guess I'll just write it out the long way. I was going to start not, but times x times y over 2 times x times y times y times y times z. So 10 divided by 2 is 5. X over x becomes 1. No more x's on the bottom, so y and y. And there's no more z's. Well, there's no z's on top. So I end up with 10 divided by 2 is 5. I have an x over, I have y to the second power, and I have z. So let's see if I can do this quicker. 10 divided by 2 is 5. So I have 2 x's on top, 1 x on bottom. I have 1 left over on top. So on top, there's an x. I have a y on top, 3 y's on bottom. So there's 2 left over on the bottom. And I have a z on the bottom and none up top. So, and if you want to see that a little nicer, it's just 5x over y squared z. But that's the same thing that I got here, right? So you don't need to do this craziness if you can just like see how many are top, how many bottom, and divide, you know, that sort of thing. So let's see what happens when you have negative, like x to the negative third. Well, it's easier if you sort of like, well, what might be helpful is putting this 1 here. So 1 times x. Normally you'd do 1 times x times x times x, but that's a negative 3. So it's actually 1 divided by x to the third. 1 divided by x to the third. It's easier just to show you. So x to the negative third goes on the bottom and becomes positive. If you end up with like something like this, you see how the y to the fourth is on the bottom, y to the negative fourth? Well, it comes up here. So this one went down there. This one comes up here. So I end up with y to the positive fourth. You can put the 1 if you want, but it's already there, right? Or I guess I could show you like that. You end up with 1 y to the fourth, which is just y to the fourth. Okay, let's try this. So I like to rewrite this. So this y to the negative third should go up there. So I'm going to write 6x squared over that y, since it moved up, I forgot to write it. That y moves up, so it's y positive. So the positive third power. And then I end up with 8. You see how that y to the negative third went up top, became positive. So now all I got to do is simplify this. So divide by 2, and I get 3 over 4. There's no x's. I mean, there's 2 x's on top and none on bottom, so I'm just going to write that. 3 y's on top and none on the bottom. And that is it. Cool. Okay. Ooh, there's a lot going on here. So negative 15 divided by 5 is negative 3. Well, actually, I'm going to rewrite this first. So I'm going to write negative 15 m n q over 5 m n to the third. And I see this q. So the negative fifth, that means it goes up there. So we have another q. to the positive fifth this time. Okay, so now let's try that. So a negative divided by positive is a -3. And then we have an m on top, m on bottom. There's none left over, right? They're both gone. So we just leave it out. There's an n on top, 3 of them on the bottom. So there's 2 left on the bottom. There's a q on top, there's none on the bottom. Actually, there's, how many q's total do we have here? We have 6 q's. So q to the 6th. So this really should be -3q to the 6th over n to the 2nd power. And let's do one more in yellow. Okay, so I'm going to move, oof, there's a lot going on here. So we have 2a to the 3rd. Okay, so this will come down here. This will come down here. And this will come up here. Well, we'll go up here. Let me see if I can show that better. So this negative, b to the -4th, c to the -3, these are going to go down here. And the c to the -5th will go up here. So I end up with 2a to the 3rd. And then these are down there, but this comes up, so c to the 5th equals, we have this 10 still. This a stays on here. This b stays on here. That c went up there, right? Yeah. Now let's look at this. This b comes down here. This c comes down here. Now I can get down to business. 2 divided by 10. Well, 2/10, we can divide by 2. We get 1, and then we get 5. We have 3 a's on top, 1 a on bottom, so we have 2 left over. And then we have b on the bottom. I just go in order, so a, b. B on the bottom, no on the top. But we actually have how many on the bottom? We have 1 and then 4, so we have 5. And then C, we have 5 on top, 3 on the bottom, so we have 2 left over on the top. And this, we don't usually write this 1 because everything's times 1, right? So we should write a squared c squared over 5b to the 5th power. Cool, and that's it. Thank you.